Hi, what I'm going to be doing is today introducing the Pythagorean Theorem for the very first time. What I like to do is, before I do the Pythagorean Theorem, I'm going to go through an easy example that you learned at a very young age. This is 2, and this is 3, and this is 5, and this is 7. What is the area of this piece? Well, 5 times 7 is 35. So that's the area of the large. Area of the small piece is 2 times 3, which is 6. So the area, the net area, is 29. So the area of the big piece, everything put together, is 35. Take away that little piece is 6, and the net area is 29. Well, I'm going to use that same logic to introduce the Pythagorean theorem. Let's say I have a square here. Matter of fact, I'm not telling you it's a square technically, but let's say, for here's sake, that these are all equal, and these are all equal. And I told you this was 3 and this is 4. I want you to tell me what is the area of this inside square. You know these are equal, because if these two sides are equal, I told you the square, side angle side, and we're working through complements of congruent triangle, congruent. We know it's equal. So let's look what we know. Well, the large square is equal to 3 plus 4 squared, which is 7 squared. So the area of this piece is 49. Now we have, what's the area of a triangle? Well, the area of one triangle is 1/2 base times height, which is 4 times 3, which is 1/2. I'm sorry, jumping ahead, 2 to 6. So the area of this is 6. And we have 4 of these. So if that's the case, if we have 4 triangles, 6 times 4 is 24. So let's look what I did. I first found the area of this whole thing. And now what I want to do is get rid of all these pieces. So I'm subtracting 4 pieces, and I know the area of this inside square is 25. Well, if this inside square is 25, and I know it's a square because all the sides are equal, then this has to be 5. Now let's look at it again, but this time I'm going to use letters. And if my diagram is off, I do apologize. This is what happens when you do freehand. Let's call this A and B. And these are all congruent, and these are all congruent. And I'm starting out with a square. So let's look at this. The area of the whole thing. Well, side of square equals A plus B. So the area is A plus B squared, which is A squared plus 2AB plus B squared. Now let's look at the areas of the triangles. Well, the area of one triangle, the area of a triangle is 1/2 AB. But I have how many triangles? 4 of them. So I will multiply both sides by 4. So the 4 areas of the triangle is equal to 2AB, which I'm going to subtract from here. Let's look what I'm left with. A squared plus b squared. So the area of this inside square is a squared plus b squared. Well, let's call this area also c squared. We'll give it a name. We'll call these sides c. So if this side is called c, c times c is c squared, so we can say a squared plus b squared happens to be equal to c squared. Hence the Pythagorean Theorem, which we just did. Well, Pythagorean theorems, if you notice, only works with a right triangle. So if that's the case, if this is 5 and 12, what's the length of this? 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. 169 is equal to c squared. C is equal to 13. And of course you could do quite a few of these, and this is good practice with working with radicals. But let me just do one simple algebraic question. Let's say this is x plus 1, and x plus 2. So what I can say is
can you please come down to the main office, please?
x squared plus x plus 1 squared is equal to x plus 2 squared. X squared is plus x squared plus 2x plus 1 is equal to x squared plus 4x plus 4. 2x squared plus 2x plus 1 is equal to x squared plus 4x plus 4. And when working with factoring, don't forget, you want quadratics, you want to make it equal to 0. So ultimately you'll end up with x squared, 2x minus 4x is negative 2x. 1 minus 4 is negative 3 equals 0. So now you have x minus 3 times x plus 1 is equal to 0. X minus 3 equals 0. X plus 1 equals 0. X is equal to 3. X is equal to negative 1. Length cannot be negative. Your answer is 3. And we can test it out. And we can say 3, 4, 5. And as we did in the original example, 3 squared plus 4 squared is equal to 5 squared. Thank you and have a good day.